Hi, my name is Taylor, and this is my experiment for the empirical formula of magnesium oxide. My question was, what is the empirical formula of magnesium oxide? This was my design/plan. The purpose of this experiment is to find how much oxygen is in the strip of magnesium ribbon our group was given and to find the empirical formula. My materials were a crucible and lid, tongs, a Bunsen burner, a ring stand, magnesium ribbon, a scale, and a clay triangle. For safety, you need goggles, aprons, and heat-resistant gloves. My procedure was, first you need to find the mass of an empty crucible and lid. Then you coil the piece of magnesium ribbon and place it in the crucible. Then you determine the mass of the crucible, lid, and magnesium. After, you place the crucible without the lid onto the clay triangle and heat strongly until the magnesium lights up. Once the magnesium lights up, cover the crucible with the lid immediately using tongs. After the crucible cools down to room temperature, determine the mass of the crucible, lid, and magnesium. Find the empirical formula for MgO and the percentage error. These are the pictures of the procedures. In the first picture, you could see the coiling of the magnesium ribbon. In the second picture, you could see the burning of the magnesium. The third is when we put the lid onto the magnesium after it lights, and the fourth is the cooling. The fifth picture is what the magnesium looked like after it had been burned. This was our data. The mass of crucible and lid was 40.7726 grams. The mass of magnesium and the crucible and lid was 41.4071 grams. The mass of magnesium ribbon alone was 0.6345 grams. The mass of the magnesium and crucible and lid after being burnt was 41.4410 grams. The mass of oxygen was then determined to be 0.0339 grams. This was the calculation to find the empirical formula. First, you needed to take the mass of the crucible, lid, and magnesium after being burnt and subtract from that the mass of the crucible, lid, and magnesium before being burnt, which was 41.4410 minus 41.4071. This gave us 0.0339 grams, which was the mass of oxygen. After that, we had to find the mass of magnesium, which is 0.6345 grams, and divide that by its atomic mass, which was 24, and that gave us 0.025437 moles. Afterwards, we found the same thing for oxygen. So we took the mass, 0.0339 grams, and divided by its atomic mass, which was 16, and this gave us 2.11875 times 10 to the power of negative 3 moles. Then we divided both by the smallest, which was 2.11875 times 10 to the power of negative 3. So for magnesium we got 11, and for oxygen we got 1. This gave us Mg11 oxygen. Then we found the calculations for the percentage error. Magnesium was 240 and oxygen was 40. So then we did the absolute value of 280 minus 40, which is 240, and then we divided that by 40, which was 6, times 100 gave us a percentage error of 600%. For my analysis and conclusion, we found out that our percentage error for the experiment was extremely high. The reason behind this turned out to be that our crucible was not very clean at the bottom, so it affected our measurements. The correct empirical formula for magnesium oxide should be MgO. In our experiment though, we got Mg11O. For my application and extension, I wrote, what I learned in this experiment could be applied to real life. Empirical formulas can be used by chemists who are trying to figure out an unknown compound. This can be very important because then new discoveries could be made. Magnesium oxide can be used as supplements for people who have a magnesium deficiency. It is important to know the empirical formula because people need to make sure it is safe to consume and prescribe.